the first number I see here is 150 males. So I've got 150 males, and that's probably going to be an N. That's how many males, but I don't have a subscript for it yet because I don't know if there's another group or not. Okay, and their ages, males age 20 to 24, and I don't think that 20 to 24 is anything I need. It's just a category. Okay, 72 of those live with their parents. So 72 out of 150 males live with parents. So that is a proportion. That's actually a sample proportion. So I guess basically I've got a number of males and a number that live with their parents. So I can write that as a proportion. So I'm going to call this p hat of males, M. And this will be N of the males. All right. Then it says in a similar survey of 150 females, so N of the females is 150, age 20 to 24. Okay, so the age 20 to 24 basically tells us that we're comparing apples to apples, if that makes sense. If you were comparing females ages 30 to 40 to men's age 20 to 24, there's not really a comparison. In other words, these people are at the same stage in their lives. They're, in college a little, probably finishing college, seeing who lives with their parents. So of these females, the proportion of females that live with their parents are 51 out of 150. Thank you. Okay, so we want to know, does this give evidence that 20 to 24-year-old males are more likely to live with their parents than females of the same age? So I guess we need to look at, in looking at this, does there appear to be a difference in the number alone? Okay, so let's look at the proportions. All you're doing is dividing them. So 72 divided by 150.48. And 72 divided by, 51 divided by 150 is 0.34. So the difference in the proportions, p hat of the males minus p hat of the females, is equal to what? 0.14. So there is a 14% difference. All right, so we've got proportions, and we've got two proportions, so we're going to do a two proportion z-test. All right, so let's just get started. Step 1. So we have our step 1 all written out. We need to pick our alpha of what? 0.05. Okay, so we picked our alpha, and now we are going to write our hypotheses. I'm going to write our hypotheses right up here. I'm going to do step 2 here. Step 2, our null hypothesis and our alternative hypothesis. Our null is that the difference in the proportions is what? 0. And the alternative is the difference in proportions is greater than 0. Okay, so now what do we have to do in step 3? Very good. Step 3, check your conditions. So condition 1, was it a random sample? No, it wasn't. So, okay, we're going to assume the respondents to the survey are representative of males and females age 20 to 24. Okay, it does not say it's a random sample. This is actually a better thing to do than assuming it's a random sample, is assuming that it's representative of the desired population. Okay, condition number 2 is 150 males and females is less than 10% of all males and females. 150 males and 150 females is less than 10% of all males and females. And then finally we have to check the N of males times the P hat of males, N of males times Q hat of males, N of females times P hat of females, and N of females times Q hat of females. So, I mean, we have the numbers and the proportions at the top. If there were 72 males and 72 out of 150 of them, or sorry, there were 150 males and 72 out of 150 lived at home, the 150s cancel and you just get 72. And then Q, okay, Q is, if P is 72 out of 150, Q is what, 78? Okay, so this would be 150 times 78 out of 150. Do you see the pattern? The 150s just cancel. Okay, so then for the females, there were 150 females times 51 out of 150 who lived at home, so 51, and then the other one's going to be 99. So are all of those greater than 10? Yes, so they're all greater than 10. You have to check all 4 of them when you have 2 samples. So now we can do step 4, our calculations, and I'm going to let the calculator do most of the work for me. Okay, I'm going to let the calculator do most of the work. I need to write the probability question I'm trying to answer, the probability that P hat of the males minus P hat of the females is greater than my observed difference. What's my observed? 0.14. Okay, which is the probability that Z is greater than, well, you can write down here that this is going to be pooled. Okay, you should actually know how to calculate the P hat pooled. Okay, you should actually know how to calculate the P hat pooled. The P hat pooled takes these original 2 values here. It takes those original 2 values and it, just double check what it does here. It adds them up. It adds those up and then divides by 300, the total number in both samples. So the P hat pooled, to find the P hat pooled, you're going to take 72 plus 51 and divide it by 300. So 72 plus 51 divided by 300, because that's how many altogether. And that's, if I could type it into my calculator right, 0.41, and I did too. So the P hat pooled is 0.41 here. So if you were going to fill in the formula, you would write, okay, so 0.14 minus 0 over the square root of 0.41 times 0.59 over 150 plus 0.41 times 0.59 over 150. And from here, I'm just going to let my calculator do it. I'm not going to calculate this. I'm not going to use NCDF, but I do need to write this down. So you do need to know how to calculate the P hat pooled. Now, you actually don't even have to know how to calculate it. Let me show you. If you go stat test, I think I'm going to tell you, but I might be completely wrong. So I'm just going to type in my data. X1 was 72 out of 150. X2 was 51 out of 150. And I'm doing greater than again, and I'm going to calculate. Okay, so do you see, does it give me the P hat pooled? So I've got Z is greater than, my Z value is 2.465. And the P value then, from that, the probability that Z is greater than 2.465 should be pretty small. The P value is 0.007. Compare it to my alpha. What's my alpha? Okay, so is it greater than or less than? It's less than. Okay, so let's look back here for just a second. Do you see the P hat? See how it's got that P hat down at the bottom there? There's P hat 1, P hat 2, this is P hat pooled. So you actually don't even have to know how to do it, because you'll have to know how to write things into the formula. You have to know that in a difference of proportions test, z-test, the proportion you use is the pooled p-hat. Okay, so then you could just write the numbers in after you do the test. It gives you more information down here, but not much more. All right, so we are going to step 5. We're going to reject the null. And what decision are we making then if we reject the null?
That the alternative for 8 is saying that
More.
males are willing to do it.
Okay, very good. We have evidence to say more 20 to 24-year-old males live at home. So if we reject the null was that the same number of males and females live at home. We rejected that, and we concluded that the alternative is what we're going to go with. And that is that more males live at home than females who are age 20 to 24.